M-mode echocardiography has good temporal resolution. Hence, measurements of the left ventricle are often taken with M-mode. End-diastolic and end-systolic volumes are estimated from these measurements. The stroke volume and ejection fraction are also calculated from these measurements. Please subscribe to this channel for future updates. Click on the subscribe button. Press the bell icon after that for all updates. Usually, M-mode cursor is guided by a two-dimensional image in the parasternal long axis view. The position of the cursor corresponds to the M-mode cut. The cut is at the caudal level for left ventricular measurements. The following measurements are marked out in the M-mode tracing. LVPWS, left ventricular posterior wall systolic. LVIDS, left ventricular internal diameter systolic. IVSS, interventricular septum systolic. LVPWD, left ventricular posterior wall diastolic. LVIDD, left ventricular internal diameter diastolic. IVSD, interventricular septum diastolic. From these measured values, other estimates are calculated by the computerized algorithm of the echocardiograph. EDV, end diastolic volume. IVS by LVPW, ratio of the thickness of interventricular septum and left ventricular posterior wall in diastole. In asymmetric septal hypertrophy due to hypertrophic cardiomyopathy, this ratio is increased. It is reduced in septal thinning due to anterior wall myocardial infarction. IVS percentage systolic thickening of the interventricular septum. Systolic thickening is reduced in scars of myocardial infarction as well as in hypertrophic cardiomyopathy. FS, fractional shortening. ESV, end systolic volume. EF, ejection fraction, the most important and popular measure of left ventricular systolic function. It is the ratio of stroke volume to end diastolic volume expressed as a percentage. LVPW percent, systolic thickening of the left ventricular posterior wall, can be reduced in scarring due to myocardial infarction. Here we see the measurement of E-point septal separation or EPSS in severe left ventricular dysfunction. Normally it is less than 5 mm. Here it is almost 10 mm. B hump is also seen in the M-mode of the mitral valve, indicating high left ventricular end diastolic pressure. This image illustrates the measurement of aorta and left atrium by M-mode. Aortic dimension is measured in end diastole, while left atrial dimension is measured in end systole. M-mode measurements of the right ventricle are seldom taken as this view cuts only through the right ventricular outflow tract and does not assess a major part of the right ventricle. Calculation of ejection fraction of the right ventricle is difficult due to the complex shape. Ideally, the M-mode tracing has to be timed with simultaneous ECG, but this is often not done as it is cumbersome to connect ECG leads in a busy echocardiography laboratory. If an ECG is attached, correct timing of end systole and end diastole is possible. M-mode measurements have an inherent limitation in that it is one-dimensional. Better methods of assessing left ventricular function would be two-dimensional or preferably three-dimensional in modern echocardiographs. But it is often restricted to the research scenario, again due to constraints of time. Measurements can be indexed according to body surface area to allow comparison between individuals with different body sizes. According to the American Society of Echocardiography Guideline 2015, 2D echocardiographic images are preferred over M-mode to avoid oblique sections of the ventricle. Theoretically, anatomical M-mode in which computer software corrects the obliquity can give better M-mode measurements, but errors could be there if the angle correction is high. Vivek and colleagues have published the data of 707 healthy Indian adults for echocardiographic measurements including M-mode among other modalities. Here are a couple of references on M-mode echocardiographic measurements. Please don't forget to subscribe to this channel for future updates and click on the bell icon for all updates. Thank you.